Factor 125 minus y cubed. Well, this appears to be a difference of cubes. Is 125 something cubed? Yes, it is 5 cubed. To factor the difference of perfect cubes, you write what you see without exponent 3. So that means you need to make sure everyone has an exponent 3. And then in the second set of parentheses, we're first going to square the first term. 5 squared is 25. Then we're going to smile, multiply these two together, is 5y. And then we're going to square the last term, y squared. The last sign is always a plus, and this other sign is the opposite of what you started with. So here we had a minus, now we have a plus. And that's how you factor the difference of cubes. Looking at this next example, 5z squared minus 45w squared, our first step is always to look for something common to each term. And here I notice 5 is common, so I factor out of 5, and what I'm left with inside one set of parentheses is z squared minus 9w squared. So this is factored, but is it factored completely? This now appears very obviously to be the difference of perfect squares. So we still have 5 times, and now we'll break down the first term, putting a z in the front of both sets of parentheses, and break down the last term, 1 times 9, 3 times 3, w times w. And I'll start at the end of the list, putting in a 3w. The last term is being subtracted, so the signs inside the parentheses need to be different. And when you do the difference of squares, you always need the signs to be different, so that when you get your positive 3zw and your negative 3zw, you won't have anything in the middle. So that is how you factor the difference of perfect squares. Remember to always look for something common first.